Hello everyone, welcome back. This is Engineer Hussein. So in this video, we'll be looking at another question that was presented in physics, and it's given like that. All right, so before we begin, do not forget to like and subscribe. All right, let's see what we're dealing with. So in a Daytona 500 auto race, a Ford Thunderbird and a Mercedes Benz are moving side by side down a straightaway at 71.5 meters per second. Okay, so it's sport type of question. Okay, there's a Ford. I guess everybody knows what Ford is, and the Mercedes Benz. So let's try and understand this question because we need to get a Benz. Okay, so in the Daytona 500 auto race, we have a Ford Thunderbird and a Mercedes Benz. So moving side by side down a straightaway at 70. So they're moving side by side. Let's not forget that statement. At this speed, 71.5 meters per second. And the driver of the Thunderbird realizes that she must make a pit stop. Okay, so she smoothly slows down to stop over a distance of that. Okay, so be mindful, they are moving side by side. So you have the Ford Thunderbird, and we have the Mercedes Benz. So these are moving side by side, which means that they started from the same point and have to end at the same point. But now what's going on is this. If we look at the Ford Thunderbird, what's going on is that the driver of the Thunderbird realizes that she must make a pit stop. So it's like we are moving down a straight side by side. Sorry, they're moving side by side down a straight away at 71 point. So they're moving at 70. So the Ford Thunderbird as well is moving now at 71.5 meters per second. So the driver of the Thunderbird realizes that she must make a pit stop. Okay, and she smoothly slows down. So she smoothly slows to stop over a distance of that. So she had this speed, but she then stopped and reached 0 meters per second, and this was at a distance of 250 meters. So she makes a pit stop. So let me just randomly just visualize that for everybody. So she spends like 5 seconds there. 5 seconds there. And then accelerates out, reaching her previous speed. Okay, then she will accelerate out. So from 0 meters per second, she then moves again and reaches a previous speed of 71.5 meters per second. And this happened after a distance of 350 was covered. Okay. So how far has the Thunderbird fallen behind the Mercedes Benz, which has continued at a constant speed? So the fallen distance is here. So it's like we have distance 1, distance 2 when she stopped for 5 seconds, and distance 3. So all we have to do is to find the time at distance 1, distance 2, and distance 3. And if we cannot, because we already have the time here, it's given, which was a hint that at the time she stopped, what distance did the Mercedes Benz cover? Because they were moving side by side. So when this person stopped for 5 seconds, there was a distance the Mercedes Benz covered that the Ford Thunderbird did not cover. So we need to now find the distance that is equivalent to the time the Ford Thunderbird spent for a pit stop. So let's first find the time, because in the end, they're having the same speed, which is 71.5, which is the initial speed they started with. So let's find the time. So let's say this is A, and this is B, C, and D. So let's say from A to B. So the best kinematic equation to use is x being equal to v plus v naught over 2 times t, because we have the initial and the final. And we have the distance as well. So from A to B, we have 250 being equal to final, which is 0, plus initial, 71.5, divided by 2, then times time. So if we compute this part here, using our calculators, we'll be having 35.75 T1. So I call this T1 here, is equal to 250. Then I divide by the same value, 35.75, even inside 35.75. Then I'll have my T1 being equal to 6.993006993. Therefore, I can round off T1 to something like 7 seconds. So that's like with the time from A to B. But again, from A to B, we're looking at distance 1. Then again, we need to look at it from B to C, which is at distance 2, of which you know that the time here was 5 seconds. Then we need to visualize it from C to D, which is at distance what? 3. So we know we say x being equal to v plus v naught over 2, then t. So we have the distance 350, then we have 0 plus 71.5 over 2 times t. Then the 0 is this, the 71 I'm using is that one. So basically I have 35.75 t being equal to 350. Sorry about that. So divided by 35.75, I'm having my t. Now this time here, I'll call it time 3. And this was time 2. Don't get confused. So time 1, time 2, time 3. So when I compute this, I'll end up having 9.79020099. So time 3 is equal to 9.79 seconds. So now that I have the time, what can I do with the time? I can literally just find now the total time it took now. Because from the point where they started moving side by side, which is A to D, we need to know the total time that it took for, because I'm looking at the position from A and then to D. I'm not saying that that's the end of the race. In this analysis, it's like we're looking at it from A to B. It's like I want to see if at all the Ford Thunderbird reached at the same, because I'm moving side by side. So imagine if the Thunderbird maybe reached near the Mercedes Benz. I want now to determine the distance that was there. So once I know the distance, I can now easily subtract by getting the distance from the time the Ford Thunderbird took a pit stop. So what I'm trying to say here is this. Let me try to make sense with my statement. So total time will be the sum of all the times, isn't it? Sum of time, which is time 1 plus time 2 plus time 3. So total time is equal to, I'm having 7 plus 5 plus 9.79, which will give you basically a total time of 21.755. So I'll round off my time to be 21.8 seconds. Round off to one decimal place in this case. Okay, so that's my total time. Now that I have my total time, we know that speed is equal to distance over time, isn't it? So with that in our head, we know that speed is equal to distance over time. So I'll say v is equal to change in x over t. So my interest is the time. What was the change in position that occurred? So it's v times what? T. This v represents the final velocity. So the change in position that occurred was the final, which is 1.5, times the time, which is 21.8. And this gives us 1558.7 meters. Now, this is not the distance I'm interested in. My interest is how far the Thunderbird fallen behind the Mercedes Benz, which has continued at a constant speed. So for me to know that, what I have to do first is to understand that if from here to there, the distance is 1558.7. What is this distance that had fallen behind? So I know this distance and I know that distance. If I sum up, if I say 250 plus 350, I'll get 600, isn't it? So now 600 minus what I have found to know the fallen distance. So the fallen distance is equal to 1558.7 minus 600. And this will give us what? This will basically give us 958.7 meters. And that's the fallen what? Distance. I hope this is clear and it makes sense. Like I've said, if it doesn't, at first glance it might not. So try to go through over and over again. Watch the video, or the videos rather, recursively, and you get a hang of it. If you have any queries, you can always reach me out on WhatsApp on the line 077 149 5252. Remember, slow progress is better than no progress, and let's strategize before becoming a statistic. Let's try and push for that A+.